Alright, today we're going to be looking at Chapter 4, Topic 12. So this is Chapter 4, Topic 12. We're going to be looking at how to multiply and divide complex and imaginary numbers. You can ignore this. Alright, so let's take a look at number 1. So first of all, we are going to multiply the numbers together. 5, 3, 15 times negative 2 is negative 30. Multiply the i's together. I times I is I cubed. Alright, we do want to simplify this. So if you remember, I should never have an exponent on it. So you have to recall back to the cycle of i's. I to the first is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. So this I cubed would become negative I. And negative I times negative 30 is just 30I. Alright, so that's our simplified form, 30I, because the I squared inside the I cubed becomes a negative 1. Alright, now number 2. Number 2 is 5 plus 2I times 4 minus 7I. So what we're going to do here is we're just going to use the distributive property. So to use the distributive property, we're going to multiply the 5 by each of these, the 2I times each of these. And then we'll simplify as we go. 5 times 4 is 20. 5 times negative 7I is negative 35I. 2I times 4 is 8I, and 2I times negative 7I is negative 8I squared. Now, keep in mind, negative 8I squared. I squared is negative 1, so negative 8 times negative 1. This is actually just plus 8. It's just a positive 8. Now, at this point, we simply have to go through and combine the like terms. 20 plus 8 is 28. Well, actually, we're not combining like terms. We're combining the real parts and the imaginary parts. So 20 and 8 are real, so we add them. Negative 35 and positive 8 is negative 27I. Alright, so that would be our product of these two complex numbers, because 5 plus 2I is complex, 4 minus 7I is complex, and we get a complex number, 28 minus 27I. Alright, let's take a look at number 3. 8 minus 3I, negative 7 minus 2I. Alright, 8 minus 3I, negative 7 minus 2I. And we want to find the product of these two. So we will use the distributive property like we did before. 8 times negative 7, negative 56. 8 times negative 2, negative 16I. Negative 3I times negative 7 is positive 21I. And negative 3I times negative 2I is positive 6I squared. But remember, this I squared is negative 1. So this is 6 times negative 1, which is just negative 6. So now we combine the real parts and the imaginary parts. Negative 56 and negative 6 is negative 62. And then negative 16I plus 21I is positive 5I. And that would be our product, negative 62 plus 5I. Now, if you look at problem number 4, these are called complex conjugates, 3 plus 2I and 3 minus 2I. The reason that we're called complex conjugates is because their real parts are the same, 3 and 3, but their imaginary parts are opposite, plus 2I, minus 2I. Complex conjugates are important because when you multiply them together, your product is real. When you multiply these two together, we will no longer have an imaginary number. We'll have a real number. Now let's see what that looks like. So 3 plus 2i, 3 minus 2i. So let's use the distributive property to multiply these together. Three times 3 is 9. 3 times negative 2i is negative 6i. 2i times 3 is positive 6i. And 2i times negative 2i is negative 4i squared. But remember, I squared is negative 1. So this is negative 4 times negative 1, which is positive 4. But also, look at here, the I portions are canceling. Negative 6i and positive 6i are canceling. So all we have left is this 9 and this 4, which gives us 13. That is what makes those a complex conjugate, because they, when you multiply them, they no longer have an imaginary part. And this all happens because the imaginary part is opposite. And this is actually going to come in handy in just a second. This is a technique we're going to use for dividing complex numbers. Alright, so if we take a look at number 1, this is a division problem. We have a complex number on top, 4i. We're dividing a complex number on the bottom, complex number on top is 4 plus I. We're dividing a complex number on the bottom, 5i, and we want to divide these. Now, if you think about division, division is just another form of multiplication. This is actually very similar to what you have to do to add fractions, because we need to turn the denominator real. And how do we turn something real? Well, we just saw that a complex conjugate will turn something real. So what we're going to be doing, 4 plus I in the numerator, 5i in the denominator, we need to multiply the numerator and denominator by the same number. And that number needs to make the denominator into a real number. So what we're going to be doing is multiplying the numerator and denominator, multiply both the numerator and denominator by the complex conjugate of the denominator. The complex conjugate will have the opposite sign of the imaginary part. So if we look at the bottom, 5i is the imaginary part. So the complex conjugate would be negative 5i. So we're going to multiply the numerator by negative 5i, and we're going to multiply the denominator by negative 5i. We're going to have to use the distributive property separately on the numerator and denominator to get a new numerator and a new denominator. So if I distribute the negative 5i, negative 5i times 4 is negative 20i, and negative 5i times I is negative 5i squared. In the denominator, I have negative 5i times 5i, which is negative 25i squared. But remember, these I squareds are really just negative 1. So negative 5i squared is negative 5 times negative 1, which is just positive 5. And negative 25 times I squared is negative 25 times negative 1, which is really just 25. So what we're looking at on the top is negative 20i plus 5, and on the bottom is just 25. Now I'm going to rewrite this. I'm going to rewrite the numerator because it should, well actually, I'm going to rewrite the numerator because the 5 should come first, and the 20i should come after. So the real part should always come first, so it's 5 minus 20i over 25. Alright, so now the denominator is real at this part. 25 is real. Now, this part is where I'm going to split the denominator. And what that means is I'm going to distribute the denominator to the real part and the imaginary part. So the real part is 5. So it's going to be 5 over 25. The imaginary part is 20i. So it's going to be 20i over 25. And then I'm going to simplify each of these fractions. 5 over 25 simplifies to 1 over 5. And 20 over 25 simplifies to 4 over 5i. And this is the quotient. When I divide 4 plus I by 5i, both of those are complex. My quotient is complex, 1 over 5 minus 4/5 I. That's my quotient. That's complex. That would be my answer. Number 2, 2 plus I over 1 minus I. So I need to turn the denominator real. So I have 2 plus I over 1 minus I. The denominator needs to be real. So I'm going to multiply the top and bottom by the complex conjugate of the denominator. The denominator is 1 minus I. So the complex conjugate is 1 plus I. The imaginary part is opposite. So 1 plus I in the numerator and 1 plus I in the denominator. I'm going to use the distributive property. So the 2 gets distributed, the I gets distributed. So 2 times 1 is 2, 2 times I is 2I, I times 1 is I, and I times I is I squared. I'm going to do the same thing to the denominator. 1 times 1 is 1, 1 times I is I, negative I times 1 is negative I, and negative I times I is negative I squared. But remember, I squared is just negative 1. So this is plus negative 1 or just minus 1. And this is minus negative 1 or just plus 1. So if I combine the real parts up top, and remember these i's cancel out, plus I and minus I cancel out. So the denominator is just 1 plus 1, so I have 2 in the denominator. In the numerator, I combine the real parts, 2 minus 1, which is 1, so this and this make 1, and then 2i plus I is 3i. Now that I've made the denominator real, instead of it being imaginary, the denominator is now a real number, it's 2, I can split it to each of the parts. So the real part is 1, so it's 1 over 2. The imaginary part is 3, so it's 3 over 2i. And this would be my quotient. I have a complex number 2 plus I. I divided a complex number 1 minus I. My quotient was also a complex number, 1/2 plus 3 over 2i. Alright, so the homework for this, Chapter 4, Topic 12, page 51, 13 through 16, and page 52, 16 through 18.